Hello guys, welcome to the first lecture on this practical course on STAAD Pro software. So here the term STAAD Pro stands for Structural Analysis and Design Program. Analysis means finding out bending moments, shear force and reaction values, and the term design means finding out the reinforcement values using the bending moments, shear force and reaction values. So let's now look at the minimum size of beams and columns recommended by IS codes. So for a structure which is situated in zone 2, the minimum width of the column is equal to 9 inches, which is approximately 230 mm. However, for zone 3, 4 and 5, as per clause 7.1.1 of IS 13920/2016, the minimum width of the column is equal to 300 mm or 20 times of dB, whichever is larger. So let me show you this clause in IS 13920 code. So here you can see that as per clause 7.1.1, the minimum dimension of a column shall not be less than 20 times of dB and it shall not be less than 300 mm. So here dB means diameter of largest longitudinal reinforcement bar in the beam passing through or anchoring into the column joint. So what is the meaning of this point? So here the code has explained it with the help of a figure. So here you can see that there is a beam that is connecting this column. So whatever the reinforcement that you have provided inside this beam, obviously that reinforcement you should extend inside the column, which is having a length equal to the development length. So whatever the reinforcement bar that you have provided inside this beam, that reinforcement bar you should multiply it with 20. So for example, if you have provided 16 mm bars in the beam, then you should multiply it by 20. So 16 into 20 is equal to 320 mm. So your minimum dimension of that column should not be less than 320 mm, as well as it should not be less than 300 mm. So we will provide, let's say, the minimum dimension as 350 mm. So that will satisfy both the criteria. Similarly, the second diagram is also showing the same clause, that is, if we have a continuous beam like this, then for that continuous beam, whatever the reinforcement that you extended for the continuous beam, you should simply multiply the diameter of the bar by 20. So if you have provided 20 mm bars, then multiply it by 20, so that gives 400 mm. So simply the minimum dimension of the column should be more than 400 mm, and as well as it should also satisfy the second clause, that is it should be also more than 300 mm. So I will provide the dimension of the column as, let's say, 450 mm. So that will satisfy the both clause as well. Now coming to the minimum dimension of beam, the minimum width of the beam as per the clause 6.1.2 of IS 13920 is equal to 200 mm. So let me show you this clause in the IS 13920 code. So here, as you can see, it is clearly written in 6.1.2 that beams shall not have a width less than 200 mm. So we generally provide a beam width of around 9 inches, which is 230 mm, to satisfy this minimum width criteria of the beam. Let's now discuss about positioning of columns. So the first point is that the columns should be preferably be located at or near the corners of the building and at intersections of beams or walls. So let us apply this first point in our AutoCAD plan. So here, as you can see, that we have provided the column at the corner of the wall, a corner of the building. Similarly, here also we have provided the column at the corner of the building. Similarly here, and similarly here as well. Similarly, wherever there are intersections of the walls, there also we will provide a column. So for example, here I have provided a column. Here this wall and this wall is getting intersected, so here I have provided a column. Similarly, here I have provided a column, and so on and so forth. The second point is that you should avoid large span of beams and avoid large center to center distance between columns. So for economical design, maximum center to center distance between columns should not exceed 18 feet, while the minimum center to center distance between the columns should not be less than 8 feet. So here as you can see, for example, the center to center distance between these columns is around 12.5 feet. However, here I have provided a column at a distance of 21 feet, which is not satisfying the 18 feet maximum distance criteria. However, that is okay for me, because why I have not placed a column near is that if I place the column, this column and this column less than 21 feet, then somewhere it will occupy my central space of the drawing room, and that will obstruct my space of the drawing room. Hence, I have not placed my column at a distance of 18 feet, and I have exceeded that criteria, and I have placed my column at a distance of 21 feet. Now, once you have positioned the columns, the second part that you should look at is the orientation of columns. So, for example, here I have oriented my column such that my depth of the column, that is larger dimension of the column, is parallel to y axis. However, here in this case the depth of the column is parallel to x axis. So, how I should decide my orientation of columns? So, the first point is that you should avoid large projection of columns. So, as you can see in this plan, if I place my column such that the depth of this column is parallel to y axis, then it will restrict my opening of the door. Hence, I should place this column such that my depth of the column is parallel to x axis, so that my opening of the door is not restricted. Hence, I have placed the column like this. Similarly, for example, if I place this column horizontally, that is my depth of the column is parallel to x axis, then it will restrict my space inside the kitchen. So, hence I have placed the column like this and not orienting horizontally. So, the first point that you must look at is that orient your column in such a way that it should not create projection inside the room. The next point is that orient the column so that the depth of the column is perpendicular to major axis of bending. So, what is the meaning of that is that, for example, I have 4 columns like this. The center to center distance between these columns in the x direction is 15 feet, while in the y direction it is 8 feet. So, obviously, my major axis, as you can see in this figure, that is the perpendicular to the 15 feet, while the minor axis is perpendicular to 8 feet. So, here whenever the load will be applied in the x direction, then my column will bend or my columns will sway in the x direction. So, I should keep my column in such a way that I can take the advantage of moment of inertia. So, hence I will place my column in such a way that my larger dimension of the column is perpendicular to major axis. So, here you can see that it is oriented in such a way that my larger dimension is parallel to 15 feet. So, let us apply this. So, here you can see that the distance of these two columns is 21 feet in the y direction. However, in the x direction it is around 13.5 feet. So, obviously, I will place my column such that the depth of the column is parallel to 21 feet, or in other words, my major axis of the column is perpendicular to depth of the column. Now, coming to the positioning of beams, it is really simple. That is, I should place my beams under the walls, and I should avoid large spacing of beams from the deflection and cracking criteria. So, guys, that's all for this video. You can like, share and subscribe to my channel so you don't miss out any future update of this practical course. See you in the next video.